Okay, so welcome to Starters 162. We'll start with div2a. Div2 is adjacent sum array. So you get an array of n minus 1 integers like 7 comma 9, and it will be shuffled, and you need to make an array a such that the sum of adjacent integers is the is bi. So how can we achieve this? Is we first we ensure that the array is in increasing order, because we needed to be in increasing order so that we can always ensure that there is an answer. Then we initialize the first element to be 1, and then from there we can choose greedily what the next element will be. Like we can choose the next element and then make it into whatever we want depending on the value there. So for 7 comma 9, you would first choose 1. Then then 7 minus 1 is 6, so you will choose the second element to be 6. Then 9 minus 6 is 3, so you would choose the third element to be 3. So one was it would be 1 6 3. So does anyone have a doubt in that approach? Hello, anyone? Doubt?
No.
uh, yeah,
I
the
tried
code
something
is,
similar, but still stuck in second test tube.
what was your approach?
I tried to take wait. I tried to take one like a0 is equals to b0 plus b1 minus b2 like this and divided by 2. Like you told, similar approach, something like that. I got
You're
the
making the you're making the middle element be the average of the adjacent two, like that.
yes, I tried something similar.
um no, like what was your formula again?
No, I didn't thought it.
No, plus you also have a problem with integer division.
Oh, okay.
Are you taking average or you are dividing the first element into two parts? You are doing something like that.
Tell me what you're doing again. If you have some array 4, 8, 10, what are you doing?
Like uh,
What
uh,
are you doing here?
A0, like A is my array which I have to find, and B is
Yeah.
array which is given. So I made it like A0, like
Okay.
first element. A0 is equals to B0 plus B1 minus B2 divided by 2.
4 plus 8 minus 10 by 2. 1.
Yes, something like that.
Where is this formula coming from, that a0 plus a1 minus a2?
It is purely brute force.
Brute force.
Yes.
Okay.
I saw
I don't
something similar, so I was trying.
Oh no, no, I don't think that formula is right itself. I don't think the sum
Oh,
would yeah. And plus integer division you always have to be careful because you lose out numbers when it rounds down.
mm, yeah.
Ensure, yeah, there's lots of implementation problems with this kind of thing. The easier thing is just be 1, then 4 minus 1 is 3, then 8 minus 3 is 5, and 10 minus 5 is 5. That's the easier method. Okay.
Sorry,
Like
your
that.
this was tracking. Can you explain once more?
So if 4, 8, 10 was the array, then I
Yes.
would choose I'll first initialize the first element of my answer array to 1, okay? Then for all of these elements, I do 4 minus 1, that is 3. Okay. Hello.
Yes, yes,
Okay. Then 8 minus 3, the difference of these two is 5.
yes.
And then 10 minus 5, the difference of these two is again 5. So this 1355 is
Yes.
my required array. You can see 1 plus 3 is 4, 3 plus 5 is 8.
Okay, so one is arbitrary.
That hello.
Yes,
Bye
yes.
bye. Yeah, okay. So
Okay, I got it.
that's the first question. Then we'll move on to the next one, which is permutation mod k. So what does the question state? So we are given a permutation. Permutation is basically we have uh, all the numbers from 1 to n exactly once. So it's like 1, 2, 3, 4, 1, 2, 3, 4, 5 like that. Now we want to find a good array such that pi mod k. So the value at that index modulo k should not be equal to. So if we were to place, if we had a array of size 4 and our k was 3, then if we did 1, 2, 3, 4, if we made this array, this is not a good array because 1 modulo 3 is 1 and the index here is also 1 and 1 modulo 3 is again 1. So that's not a good array. But then if instead I made it as 2, 1, 4, 3, hello,
हाँ हाँ सुनिए
okay, लोग सुन सकते हो ना मुझे?
हाँ
Hello, can you guys hear me?
हाँ इशू तो नहीं मेरी म्यूट की तरह है
Okay, okay. Did I disconnected or did you? Okay, yeah. So 2 modulo 3 is 2, and then but then the index is 1, and 1 modulo 3 is 1. So they are not equal. So and similarly here also the index is 2 and not equal. And here the index is 3. So 4 modulo 3 is 1, but 3 modulo 3 is 0. These are also not equal. And then again 3 modulo 3 is 0 and 4 modulo 3 is 1. They are also not equal. So for so this is what we want to achieve. So how we can achieve it is first thing to notice is we can swap two numbers, right? So if I have some number I and I plus 1, if I just swap these two, we will always have a different modulus. Okay, like I plus 1 modulo k and I modulo k different. It is never equal except if k is 1. So that is our base case. So k is equal to 1 is a base case. So for all other options, we can always swap I and I plus 1. So when the length of your array is even, tab you can just swap all I and I plus 1 and you'll get your answer. So uh, if we had like a length of array 6 and k equal to 3, then we could just make it as 2, 1, 4, 3, 5, 6, 5 because k is not 3 and it is even. So we can just swap the adjacent two elements. But now what if we have a odd number? In the case of an odd number, so like if we have 7 and 3, so in this case what we can do is we'll first follow our same swapping logic for the first four elements, 2, 1, 4, 3. This is similar. But then for the next 3, 5, 6, 7, we just we need to swap these three in any way such that they become good. So it could either be 5, 6, 7. or it could be 756, or it could be 675. So if any one of these is good, any one is good, then we can use that as our use that as our good array instead. So that way we can go 2143 and then 756. Did did everyone understand the approach? Hello.
Yeah, yeah, got it.
मैं नहीं समझा तो बोल. हाँ ठीक है. तो इसका इम्प्लीमेंटेशन अभी मेरा थोड़ा सा गंदा है. क्या? Okay. We always know there will be at least one cyclic shift that is valid. Oh, yeah, it
have
is
a
valid with
different truth.
always one.
Like
क्या है अप्रोच?
uh,
हाँ, इसमें
ऐसा
मैंने
है कि
किसी
n
के
mod
ऐसे
के
बहुत सारे अप्रोच. क्या हुआ बोल.
n mod के equal to 1 है ना, तो cyclic
हाँ,
shift by 2, and then अगर n mod k is not equal to 1, then just cyclic shift by 1, उतना ही काम चल जाता है.
चल जाता है क्या?
एक बार cyclic shift. हाँ.
अरे क्रेजी, ये पैटर्न
और
नहीं
बस
देखा भाई
n
मैंने.
mod, बस ये कि अगर n mod 2 equal to 1 है और k equal to 2 है, then obviously -1.
Hmm.
हाँ या.
वो एक केस ही है बस.
अच्छा अच्छा, this was the ओके. अरे मैंने पता है, आई सॉ माय अप्रोच एज आई डिड लाइक अ परम्यूटेशन वाला ब्रूट फोर्स, एंड देन आई सॉ कि ये स्वैप करने वाला चल रहा है, तो मैंने स्वैप करने वाला इम्प्लीमेंट कर दिया. तो इफ
हाँ,
यू
ये
सी माय
मैंने भी सोचा
कोड.
था, बट फिर इट्स
तेरा
टू बिग.
तेरा टीएलई क्यों नहीं दे रहा? कैन यू एक्सप्लेन?
मेरा
हाँ.
मेरा कोड तो बहुत मेरा कोड टीएलई कौन सा वाला क्वेश्चन है ये ना. uh, तुझे कौन ओके वेट. Okay, this code is actually very bad. So what I did was I brute forced all the possible answers, and I checked ki what all arrays are good, what all permutations are good. So why I did this is I was trying to find a pattern because I could not come up with it constructively. This is a very common method for some questions where brute forcing helps you find a pattern. So when I brute forced, I realized that जब जब n even है, तब I can just print this key I and I plus 1 get swapped. That's it. I can just
Hmm.
print this. तो अगर n odd है and k equal to 2 है तब -1 है.
Yes.
Similarly अगर k equal to 1 है तभी भी -1 है.
Yes.
Then in the last cases अगर n odd है and k is greater than 2, in that case मैं n-4 तक बस नॉर्मल ऐसे जो पहले किया था वही, लाइक adjacent element swap कर दे रहा हूँ. दिस इज adjacent element swap करने के लिए. देन यहाँ पे मैं बस ANS is just a 3 element. ओके अच्छा, तू ये नेक्स्ट परम्यूटेशन की वजह से पूछ रहा है.
या डू वाइल लूप मेरे को उसको ऐसा लगा कि टीएलई
ओके ओके,
देना.
नेक्स्ट परम्यूटेशन नॉर्मली विल ऑलवेज गिव TLE, बट इफ यू नोटिस मेरा ANS का लेंथ इज ओनली 3. ओके, सो नेक्स्ट परम्यूटेशन only runs 3 factorial times. So
ओके.
3 factorial is 6, so this is only running 6 times. There's only 6 combinations here.
व्हाट इज दैट एएनएस अरे?
ANS is basically, मैंने बोला ना कि अगर ऑड लेंथ का है, लेट्स से 7 है, राइट. So I'll have 1 2 3 4 5 6 7, right. तो मैं इन दोनों को स्वैप कर दूंगा. ठीक है. एंड मैं इन दोनों को स्वैप कर दूंगा. ओके. एंड देन ये ANS जो है ना, ANS में ये तीनों रहेंगे. एंड आई जस्ट लुक फॉर एनी ऐसे साइक्लिक इधर साइक्लिक शिफ्ट ही होगा, वो मैंने प्रूव किया था. बट इम्प्लीमेंटेशन मेरे को करना नहीं था, तो मैंने बस नेक्स्ट परम्यूटेशन लिख दिया.
तो
आई जस्ट लुक फॉर एनी परम्यूटेशन ऑफ दिस दैट इज गुड.
yeah, what you
समझा.
are doing is dividing into blocks and then finding a permutation in the block. ऐसा
Yeah,
कुछ?
मतलब ये टू वाले ब्लॉक्स का तो मेरे को पता है कि क्या परम्यूटेशन है, बस उनमें उल्टा कर देना है। बस ये जो लास्ट वाला ब्लॉक है ना, इसके लिए मेरे को परम्यूटेशन निकालना है ना। तो ये
हम्म,
मैं ये जो तीन, बस ये तीन का एरे बना दे रहा हूँ। तो इन द केस ऑफ ए एन एस, तो पूछा ना क्या है। ए एन एस वुड बी, ए एन एस वुड बी, अगर अगर सेवन का केस है, ठीक है, एन इक्वल टू सेवन, ए एन एस वुड बी 5 6 7, ओके।
हम्म,
देन इस पे आई जस्ट रन दैट परम्यूटेशन वाला, एंड आई फाइंड कि कौन सा वाला परम्यूटेशन इज गुड। जो
हम्म,
भी परम्यूटेशन गुड है वो यूज करके प्रिंट कर देता हूँ। सो दिस इज एक्चुअली स्लाइटली ऑन द वर्स्ट साइड फॉर इम्प्लीमेंटिंग।
yeah,
देख सकते हो काफी गंदा इम्प्लीमेंटेशन आया, बट इट वाज, या, इट वर्क्स, दैट्स व्हाट्स इम्पोर्टेंट।
okay.
Okay, yeah, so for a better solution, how do I? वाला है? हार्दिक तेरा भी दिख, हार्दिक तेरा किधर है? ठीक है, सो फॉर दिस,
वही दैट वो पहला वाला मैं ही हूँ।
अच्छा वो तू, अरे ये मैं कब से पूछ रहा हूँ, ये तेरे को बताने नहीं हुआ
अरे
भाई,
मैं
मैं
कब
वही
का बताया हूँ, तुम लोग ने देखा
नहीं
नहीं।
इसी, नहीं नहीं कब का तो नहीं बताया, ये मैं कब से सोच रहा हूँ कि कौन है
अरे
भाई आके।
बहुत पहले।
ध्यानेश मेरे को पूछता है तू है क्या कांडू सी, मतलब भाई मैं दो अकाउंट से एक साथ कैसे दूंगा। ए है, एन है, के है, ए है, एन प्लस वन है, फॉर एल एल आई इक्वल्स टू वन। तो सबसे पहले ही इज डूइंग नॉर्मल, दिस इज लाइक वन साइक्लिक शिफ्ट, एंड देन फॉर एल एल आई इक्वल्स टू जीरो, आई लेस देन एन। अरे सर ये क्या किया है? ओके यू आर जस्ट साइक्लिंग, ओके। ओके सो, ओके, सो व्हाट जनरल इज डूइंग इज, पहले ये चेक फंक्शन है, हाँ भाई, नॉट लिटरल ब्रूट फोर्स, लिटरल ब्रूट फोर्स तो मैंने लिखा हुआ था, वो तो 11 पे भी टीएल ही देता था। So what general is doing is, he wrote a check function. The check function takes a array A and it checks whether it is good or not. So if I modulo k equal to A of I modulo k, return false. So this function is checking whether the array is a good array. तो ये वाला लॉजिक समझाना कि चेक फंक्शन कैसे काम कर रहा है। Then
Yeah.
after that, he just goes over all the cyclic shifts of the array, ठीक है। तो it can either be 0 से लेके n तक। he then check ये वाला array जो है गुड है, अगर उसने अभी जितना शिफ्ट किया है वो वाला array गुड है। if it is good, then he will just print out all of it, he'll print out the answer. if it is not good, then he shifts it again, again goes back, again checks, अगर वापस गुड नहीं आया वापस शिफ्ट करेगा, एंड सो ऑन, एंड इफ ही एग्जिट्स आउट ऑफ इट, मतलब कभी भी उसे गुड मिला ही नहीं, तो फिर वो -1 कर देगा। दैट्स इट। डज एवरीवन अंडरस्टैंड दिस कोड? किसी को ये अप्रोच में डाउट है? दिस इज बेसिकली ब्रूट फोर्स की, यू जस्ट कीप ऑन शिफ्टिंग इट वन टू द राइट, एंड देन यू कीप ऑन चेकिंग अगर ये वाले शिफ्ट में इट इज अ गुड array और नॉट। हाँ, या, 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 yes,
Like I had this approach, but when I was doing it on paper, it was failing for cases where difference between n and k was equal to one. Hmm. Anyways.
yeah.
Yeah.
रिमूव कर सकता हूँ इसको।
अनम्यूट कर भी बोलता
रिमूव
हूँ।
कैसे करते हैं इधर
वो यूजर वॉल्यूम के नीचे।
ठीक है ठीक है। अनम्यूट, अरे अच्छा इसको म्यूट किया हुआ है किसी ने।
ये
अच्छा मैंने म्यूट किया हुआ है, अरे बोल
वही
सचिन।
बोल रहा हूँ तब से। अरे नहीं, मैं क्या कर रहा था कि आई जस्ट शिफ्टेड बाय एवरीथिंग बाय के, तो वो एरर लाइक वो गलत क्यों है?
शिफ्टेड
मैंने
एवरीथिंग बाय के।
1 to n ले लिया and just shifted like rotate the entire thing by k.
एक वो गलत क्यों है पूछने से अच्छा तुम हमें बता वो सही क्यों है।
लाइक उससे एवरीथिंग के वाला मॉड हमेशा वन ही रिटर्न करते रहे, काइंड ऑफ चीज ऐसे सोच के किया था मैंने।
नहीं तो अभी अगर तेरा एन मॉड्यूलो के जो है जीरो हुआ, मतलब अगर 6 और 3 हुआ,
हम्म,
तो फिर तू सेम मॉड्यूलो पे शिफ्ट करा ना वापस। सिक्स
हम्म,
सिक्स पे था, तू 6 को 3 पे भेज रहा है, समझ रहा है।
अच्छा ओके ओके। हाँ ठीक है, समझा समझा।
हाँ तो वही के वॉज, अच्छा के वॉज ट्रिकी। ओके, समझा अभी सबको, सबको सारे अप्रोचेस समझे।
I had one doubt.
या
Like in your solution, you are swapping, right?
या
So instead of finding at last permutation, we will just swap all till even in even numbers, like till except the last odd one, and then at last two will swap. Would that work?
लास्ट टू।
Like
Okay,
if
last two will swap. I don't know if it will work, but one thing that I know will work is you can, for the last element, you can search over the whole array for any number such that, but in that case, again, you have to search for an array such that the index, like you have to search for an element such that the element itself can go to the last place, and the index here can hold the element that is currently at the last place. So this means that you are anyway looking for a triplet. You get what I'm saying, right? Like there would be, you have your last index, you have the element at the index that you find, and then the index of that element. So these are anyway three different modulo. So like you, so it is kind of like choosing three only.
okay,
Get what I'm saying?
yes,
Like 1, 2, 3, 4, 5, 6, 7. I also actually approached it exactly how you did. That was my initial approach only. And then I just realized that like if I'm anyway looking for a triplet, then I can just use the same
हाँ, do you want to continue? Shit. Issue. As bro, as
Hello, can you guys hear me?
Yes.
अरे हाँ सॉरी, नेट नेट इश्यूज. तो मैं किधर था? व्हाट वाज आई एक्सप्लेनिंग? और डाउट्स है परम्यूटेशन मॉड के बारे में? Okay, then I'll move on to the next one. So next question is empty the string. So empty the string. You are given a string S. It contains the characters A and B, and you can perform the following operation. That is, you choose a alternating subsequence T. Alternating subsequence मतलब A B A वैसा, and delete it from S. For example, if string is ABBA, you can choose ABA, delete that, and you get just B. And we need to find the minimum number of operations to convert S to an empty string. So how do we do that? So the biggest observation here is something called a greedy observation, which is that you notice that if I give you any string, right, A B A B B, like I don't not I'm just writing for this. If I give you any string, you if you want to convert it, if you want to convert it to an empty string, you'll have to remove the first one. पहला वाला तो निकालना पड़ेगा, बराबर. अभी अगर आप पहला वाला निकाल ही रहे हो, इसके वेट, हेलो. आई थिंक मुझे किसी की भी आवाज़ नहीं आ रही. एक मिनट.
म्यूट कर देते एक बार। हाँ
हाँ
हाँ,
अभी आ रही है, मुझे अभी आ रही है. प्रॉब्लम हो रहा था वो.
सबको म्यूट कर दिया है।
या yeah, okay. So just write some string of A's and B's. Okay, like A B A B B A, anything. Okay. So now the observation here that everyone needs to make is, अगर आपको empty string बनाना है तो आपको जो सबसे पहला एलिमेंट है वो निकालना पड़ेगा, जो पहला A है, राइट. एंड नाउ सिंस वो आप A को निकालने के लिए एक ऑपरेशन कर ही रहे हो एनीवे, oh sorry, and if you're removing and if you're using up one operation to remove that A anyway, then you will always also greedily choose whatever the next B is, right. Then you will choose, then abhi, then you again removed B, so you'll want to remove whatever the next A is, then you'll want to remove whatever the next B is. You are trying, because you will just greedily always try to maximize whatever your operation what like how many characters you're removing with your current operation. Okay, so now we know that greedily we need to count how many operations we require. That is all that we need to count. So uh yeah, how many such operations required. That is what we need to count. So since we are counting greedily, we can always maintain a count of how many current operations are going on, like at every index how many current operations are going on. So initially there will be no operations, then every time you see, yeah, so initially there will be no operations required, you don't need any operations. Oh, okay, yeah. So initially there are no operations going on, then you come to the first A. Okay, so at the first A you need to remove this A. So you will start an operation on A. So we'll call it a AOP. Let's call it a AOP. Operation is equals to 0. Then just write AOP equal to 1. So now when you come to the next B, instead of starting a new operation here, you'll see that since AOP equal to 1, you can just continue on that operation and remove the B here. So at that B, you'll make AOP equal to 0 and BOP equal to 1. And BOP equal to 1. Yeah. So does everyone get what's happening here? What's happening here is I'm this AOP and BOP is basically maintaining key how many operations are going on up till this index where I have seen A last, and how many operations are going on up till this index where I have seen B last. Yeah. So now the next case is when do we start a new operation, right? So now for this next A, it will again get counted in the same logic that AOP becomes 1, because in a singular operation we can remove this A also, and BOP remains 0. Okay. But yeah, operations is 1, yeah. Starting and but now when you come to the next day, so now we don't have any BOP is 0. We need a BOP to be able to continue on to remove an A because it is an alternating thing. So here we don't have that. So in this case now we need to start a new operation. So we increment ops, yeah, and then we add a AOP. Correct. So now we can just keep on doing this. Like at every index, we check if either we can continue one of the previous operations or we can start a completely new operation. We can check this at every index. Yeah. Yep. And display be same. Yeah. 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 So operations doesn't get updated, so that's why you just output 2. So that is how you do it. So at every index, you check if either I can extend one of the previous operations or you'll have to create a new operation. That's it. Did everyone understand how the approach is? I think third, sorry, second year, kya? हाँ. So ops is the total number of operations. AS is the operations that have ended in A's, and BS is the operations that have ended in B's. Then you just go through every index. If at that index you have an A, there are two cases. Either you already have some operations that were ending at B's. If you already had operations that are ending at B's, then you can just use one of those operations and continue them on. Okay, you can, yeah, yeah. So if you are able to extend it, then you just extend it. Otherwise, you'll have to add a new operation. And then at the end, you just print out the number of operations. Does everyone understand how this is? The code is easier in the approach if anyone has any doubts. Everyone understood, right? बस एक बार unmute करके बोल दो कोई.
Yes, I understood your method, but actually tried doing the greedy using only one counter. But like I don't get where it is failing. Can you check?
Uh, one counter अच्छा भेजा है क्या? White solvent and CNN. Oh, this is kind of hard to understand. ये logic क्या है इसके पीछे? One
So
counter से क्या try कर रहा है?
I am increasing the counter if I enter counter A and else I'm decreasing the counter. And if like the counter exceeds the max that is there, I am adding one operation. Like for example, the test case is AAAB. So
Yeah.
I am adding like AAABBB. So I am adding till like counter becomes 3. I am adding 3 operations to the answer. And then as I encounter B, the counter decreases. So new operation won't be
Uh,
created.
but then BPPAAA also, like an operation can start at B also.
Yeah, so I'm taking the absolute value of the counter.
Okay. Sounds okay. What is max? What is
Uh,
max?
double A B double A.
Yeah, I think there's one flag varied div 1 में शायद से बहुत निकाल दिया. वो अच्छा नहीं अरे नहीं. ओ 6 stars and 7 stars निकालते हैं क्या? अच्छा. हाँ. मैं रैंक देख रहा था. मैं देखा हुआ है 41. मैं सोचा ऐसा कैसे. सच्ची. रुक जा. अरे नहीं, मुझे 2035 दिखाया. रुक जा. ओ 2055. डिथ्रोनिंग विथ्रोनिंग वाले बातें मत कर. ठीक है, मैं कम्पिटिटिव हो जाता हूँ थोड़ा. व्हाट वाज 3 ओनली? रुक जा. Where should मैं तो ये पे हूँ। मैक्स वैसे भी किसने तुम ओके सो हुआ इज रेड मैक्स। हार्दिक ने पढ़ा रहेगा। हाँ तूने पढ़ा है वो तूने पढ़ा है पता है क्या सिर्फ 12 साल में डिव 2 में। अरे भाई जब मैं डिव 2 में था तब मेरे को ऐसे क्वेश्चंस नहीं मिलेंगे। व्हाट डिड यू डू। ओ अरे दिस इज आई थिंक दिस इज करेक्ट ओनली ना क्या है ये। या you extend out an interval L comma R। वो L comma R will always contain some number 1 से लेके 0 से लेके L minus R तक सारे numbers रहेंगे। So you just keep doing this until L comma R exceeds the L comma R given in the question and then उसके बाद में you yeah 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 बराबर। ओके do that change then ना that's a small change तुझे बस एक range लेना पड़ेगा फिर। सबमिट तो मार अच्छा ठीक। अच्छा ओके सो एक मिनट एक्सप्लेन किस किस ने पढ़ा है बताओ एक बार। बाकास्ता एंड एम या बाकास्ता एंड एम तुम दोनों ने पढ़ा है। डिड यू
No,
गाइस रीड द मैक्स एक्सऑर वन।
No, no, no,
no,
no.
Okay,
No.
so just so I'll just explain the question once. Yeah, so there are three integers L, R, and X. Okay, we are making a set S, which is the XOR of all the numbers between L and R inclusive with X. Okay, it's the XOR of all of those numbers, and they are asking us to find the max of this set. Okay, so इसके लिए मैं स्क्रीन शेयर मारूँ क्या थोड़ा। नहीं आई डाउट मेरा वॉइस क्रैक हो रहा रहेगा ना अभी भी। क्रैक नहीं हो रहा तो ट्राई मारते हैं। हॉटस्पॉट पे हूँ। वाईफाई आया क्या। ये वाईफाई आया दिखा रहा है। मार अरे नहीं, छोड़ छोड़ छोड़, तू दिखा दे। हाँ, तो द मेन ऑब्जर्वेशन हियर, राइट, इज दैट तू कोई एक, या परफेक्ट, या जस्ट अ मिनट, हाँ। लाइक then हाँ, so go to Excalibur and draw, just write some small binary number, 6 लिख दे, 110 लिख दे। Okay, so now let's say our x is 110, okay. Now when I want the value, I first need to make the value 0. I, so for that I need 110 between my L and R. Then I need to make the value 1. So for that I'll need 111. Yeah. So basically, to make any value in the range 0 to 2 to the power of n, you need x, and then you need like wait, what was I going to say? You like you need all the numbers L to R. Wait, this is easier to explain if I share my screen, or just okay. So this is the brute force that I wrote for this. Okay. Hmm. Basically, for for uh, any mask of size, like let's say 4, and whatever I XOR it with, it doesn't matter. All of these numbers will always contain all from 0 to 15, like 0 to 15 सबके सब हमेशा included रहेंगे, and then this works for all of your all of your powers of 2. For 6 also, everything from 0 to 63 is always included. So what this basically means is, if I had let's say the value, if I just had some number, okay, let's say this is my x, okay. Then if I have all of the numbers from 1 1 0 0 0 0 0, okay, basically this whole part I made it into a 0. If I have all the numbers from this to 1 1 1 1 1 1 1 2 3 4 5 1 2 3 4 5, I need all the numbers here. Then basically I will have, like I will have all the numbers from 0 to 1 1 1 1 1, 5 ones. Do you get what I'm saying? Like if I have this interval, I have these powers of two intervals, and in those powers of two intervals I have all the numbers possible, and I'll always get all those numbers. The people who read the question understand what I'm saying?
हाँ समझो yes
Yeah. So अभी ये वाला जो interval है ना, 0 to 1 1 1, now you can just keep on expanding this for every bit, okay, also for every power of 2. तो अभी अगर मेरे पास कुछ ऐसे है 1 1 0 0 1 1, okay, then first I'll keep the interval as 1 1 0 0 1 0 से लेके 2, why is my mouse is tweaking out a bit, 1 1, this has two elements in it, this in this interval has two elements in it, okay. Then I can again expand this to 1 1 0 0 0 0 2 1 1 0 0 1 1 0 1 1 1 1 1, okay. This is again expanded. Then I can, oh right, sorry, double 0 1 1, yeah, double 0 1 1, yeah. Then we can again expand it to 1 1 0 0 0 0 2 1 1 0 1 1 1. Like you get how what I'm doing, right? You can see what I'm doing. So as I keep expanding, yeah. So as I keep expanding, I'll have an L and R here, and at some point this either this will exit my bounds here or this will exit my bounds here. So I just need to handle these two cases separately. First I'll have this and I'll greedily set these bits such that it doesn't become greater than L, but it makes sure that wherever there is a 1 in X, there should be a 1 in my min 1 also. It greedily sets these bits. Okay. अगर यहाँ पे 1 है तो यहाँ पे भी I want a 1. ठीक है, ग्रीडीली सेट करता है. एंड बड़े वाले के लिए भी यही है. अगर यहाँ पे 0 है देन यहाँ पे ऑल्सो आई वांट अ 0. जिधर भी यहाँ पे 0 है आई वांट अ 0 हियर. ओके. नो, फॉर द बिग वन, फॉर द बिग बॉय, फॉर द बिग वन. अगर यहाँ पे 0 है तो आई वांट अ 0. अगर यहाँ पे 1 है तो फिर ऑफ कोर्स 1 ही है. सो हाउ डू वी इम्प्लीमेंट दैट? वेयर इज माय? हाँ. सो हाउ डू वी इम्प्लीमेंट दैट? ओके. Sorry. Yeah, I also do not think it is needed, but this is how I know to code. Yeah, whatever strikes at the point is what we do, right? So what I'm using this best bit to know that at the end where I should start iterating from. Basically, I go to Excalibur. I only need to iterate from here, right? I don't care about these bits. Like these bits have to stay as they are. If I change these bits, then I'm going into other intervals that where I might encounter much bigger numbers, much bigger numbers which I don't really need. Okay, so that is what the best bit is for. Here the best bit would be 4. Yeah, 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 yeah. My logic is कि वो previous few bits always need to be same, right? The previous few bits need to be same. So my logic was कि I just check कि up till which bits need to keep same. Yeah, that's what I'm checking. Yeah, 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 yeah. Yeah, that's what I'm doing. You just stop there and then, oh, okay, I should continue. अरे नहीं नहीं नहीं, I'm here. Okay, so that is what the best bit is looking for. So once I have my best bit, right, I will now have a L naught and a R naught, which is the bounds which are now violating my given L and R in the question. So now first I try to either increase L naught greedily, which is I go from best bit, I decrement down, and if possible, wherever X is 1, I try to add a 1 there in max as well, in L naught as well. Okay, basically, where is my X Kali? Ah, uh, arey wow, this is very dirty. Yeah, basically, um, since there is a 1 here, I'll first try to make this into a 1 and check if it still violates L, and then I'll try to greedily again set this to 1 and make sure that it still violates L. This is what I'm greedily doing. Then I need to do the same thing for R also. Again, I do the same thing, but for R we need to check that there is a 0 at that bit. Like if there is a 0 at that bit, then we try to make it 0 in R as well and ensure that the max 2 is still greater than R. It needs to be greater than R. So that means we first try to either increment L naught to whatever it can be, or we try to decrement R naught to whatever it can be. And once we have L naught and R naught decremented, then this is some convoluted logic. I'm sure we can eliminate some part of it, as Janil said, but I'm not sure what to. So this is if L naught greater than or equal to L, then doing that first part of the code doesn't make sense. So I just ignore L. So I just ignore the max one in that case, and I print X XOR max 2. If R naught is less than or equal to R, then the second part of the code doesn't make sense. In that case, I only do the max one, X XOR max 1. And if both of them are violating, then I need to output the minimum of these two. That's what this last line of code is doing. Does everyone understand what is happening here? This wala part is easier to understand in logic. Once you understand it in logic, then this is easier. uh, समझा सबको? हार्दिक भाई,
No.
हार्दिक भाई, ये कांड डू सीपी वाला, ये भाई मैं 4 कॉन्टेस्ट से मैं 1 महीने से पूछ रहा हूँ अभी.
भाई बोले एक बार भी नहीं, स्टार्टिंग में डीपली पूछो तो आंसर दिया होना.
हाँ.
इट्स लाइक अभी मेरा बेल बन गया वो.
I have no idea what your code is doing. ग्रीडी एल को तू ग्रीडीली इंक्रीज कर. या या तेरा एल वुड बी सम बराबर. doesn't are या बराबर. या दिस इज व्हाट आई हैव एज वेल. तो एल को तू ग्रीडीली इंक्रीज करेगा while making sure that it still stays out of bounds of the L. हाँ नहीं नहीं, आई एम सेइंग कि वो लाइक ईच बिट पे जाके जिधर एक्स वन है उधर तू ये एल नॉट पे भी वन डिक्रीजिंग ऑर्डर में, लाइक बिगेस्ट बिट फर्स्ट। हाँ, देन expand it till it's out of that range ना, बड़ा वाला एल बड़ा वाला आर मतलब। हाँ तो इसलिए तो नेक्स्ट जा, तो आउट ऑफ रेंज जा और उसके बाद में ग्रीडीली हर एक बिट को इंक्रीमेंट कर। तू अंदर रहेगा तो देखो मैक्स कैसे पता चलेगा, यू नीड टू फाइंड आउट कि व्हाट कैन नॉट बी मेड ना। तो हाउ विल यू फाइंड आउट कि व्हाट इज नॉट बीइंग एबल टू मेड? समझ रहा है क्या बोल रहा हूँ? सो you'll have to go like one step outside you'll have to take. Once you're at that one step आगे ना, then you use x to greedily increment कि जिधर भी x वन है उधर you want कि तेरे ये आंसर में भी वन हो। So you just check अगर ये वन को, अगर ये वाले बिट को वन बनाने से does it still stay less than the capital L? That is what you check. So that, समझ रहा है ना? You go from, हाँ उल्टा जाना है, उल्टा जाना है। बस बिगर बिट करेंगे तो इट्स इवन बेटर देन डूइंग ऑल द बिट्स इवन। बट नाउ इफ x and 1 ll left shift, शायद वो वैसा करता है। अच्छा, ओ वाओ, ओ वाओ, या सिर्फ x and power, then you check if it fits low, then again, हाँ yeah, then now you put if, uh no, this won't work। ये तू कैसा कर रहा है? You found this number inside the while loop and then you're still inside the while loop. I thought you like, but once you find your number, you should exit the loop now. हाँ ठीक है, तो if x and pw है, then जो भी तेरा आंसर है ना उसमें यू चेक कि अगर आंसर में ये वाला पर्टिकुलर पावर ऐड करने से डज इट स्टिल रिमेन आउटसाइड एल, लाइक डज इट स्टिल रिमेन लेस देन एल। तेरे आंसर में ऐड दिस पावर, या जस्ट एडिंग दिस, add it, what is, why are you doing XOR? It won't definitely be, oh no. I don't want it to be greater than equal to L, I want it to be less than L। समझा नहीं? या, ओके, ओके। Oh, then I'm not sure। ये थोड़ा सा ऊपर था। देख वो मैक्स वन मैक्स टू जैसे कैलकुलेट किया है वो देख. I increment the interval, and once both the interval has exited, I do the. Ah, okay, yeah. That might work. Yeah, pivot speed. It's just less. No, that won't. That doesn't sound right. Actually, because less will always be a power of. ये भी मैंने भी किया था उस दिन. मैंने ऐसे बस n-2 लिख दिया. इनपुट में. इनपुट में. एल्स में क्यों जा रहा है? सी आउट जीरो एंडल. Did you understand the last approach? Yeah. No, yours is same now. We just implemented in different ways. Okay. Hello. Any doubts?
No.
Okay. 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 Yeah. Bye. Good night.